Okay, in this video we're going to look at the difference between mutually exclusive and independent events, along with the addition and multiplication principles. So for the examples I'm going to use here, we're going to talk about a standard deck of cards and a standard die. Uh, the standard deck of cards has 4 suits: spades, clubs, hearts, and diamonds. The suits are broken down into 13 cards: the ace, king, queen, jack, and then the numbers 2 through 10. And they're king, queen, and jack are what we call the face cards. Standard die is just a regular die that you're used to using in most games that's got 6 sides with either 1, 2, 3, 4, 5, or 6 dots on the sides. So we're going to look at first how many different ways there are to draw an even card from a standard deck and roll an even number on a standard die. So we're looking at 2 events that are completely independent of each other. Drawing a card from the deck and rolling a number on a die have nothing to do with one another. There's nothing about the cards that would tell you anything about the die, or there's nothing about the die that would tell you anything about the cards. And so when we're looking at that, we're looking at trying to be able to do both of those at the same time. So I want to roll the die and pull a card and determine what the probability, or not the probability, but what the number of ways are that we can do those. So we're going to let A be the number of ways to draw an even card and let B be the number of ways to draw an even number. So we look at the number of different ways that we can draw an even card or roll an even number. So to draw a card, there are 5 even cards in each suit. So 2, 4, 6, 8, or 10 in each of the 4 suits. So 5 cards times 4 suits gives us 20 different ways to draw an even card. And then with rolling an even number, a 2, 4, or 6 are the only even numbers that we can roll on a regular die. So A has got 20 different ways of occurring, B has 3 different ways of occurring. Multiply those together means there are 60 different ways that I could pull a card from a deck and roll a die and end up with an even card and an even number on the die. Now I'm going to look at what are the ways that I can draw either an even card or a face card. The difference here is that I'm looking for one or the other to happen, not to do both necessarily at the same time. And so I'm going to let A be the number of ways to draw an even card, B be the number of ways to draw a face card. What I want to point out here is the fact that these 2 events are mutually exclusive. There are no cards in a deck of cards that are considered to be an even card and a face card. So it's either one or the other, so I don't have to worry about there being any overlap. We'll talk about that one in just a second. So just like we talked about a second ago, there are 20 different ways to draw an even card. With the face cards, there's a king, queen, and jack in each of the 4 suits, so there's 12 different ways to draw a face card. So if I'm looking for how many different ways there are to draw either or an even card or a face card, that's 20 ways for an even card plus 12 ways for a face card. So I've got 32 different ways I can pull a card out of a deck and get one or the other of those 2. Now, this leads to the question of what happens if it's something that's not mutually exclusive? What happens if there's an overlap, like in this example? How many ways are there to draw a card that's either red or even? Obviously, there are cards that are both red and even, and we have to watch out for those cases. The easiest way to describe this is by using a Venn diagram. So in my Venn diagram, I have in the left circle, I have all the red cards. So I have 3 of hearts, 5 of hearts, 7 of hearts, all the way through the ace of diamonds. Then in the little overlapping section, I have the even red cards, 2 of hearts, 4 of hearts, 6 of hearts, etc. In the right-hand circle, I have all the cards that are even. So I have 2 of clubs, 4 of clubs, 6 of clubs, 8 of clubs, etc. But again, in the overlap, I have all the even numbers of the red cards. So if I count the entire red circle, there's 26 cards that are red. If I count the entire black circle, there are 20 cards that are even. In that center, though, I have 10 cards that get counted twice. They get counted as red cards as part of that 26, and they get counted as even cards. So we take the 26 red cards plus the 20 even cards, but we're going to subtract out the 10 in the middle because they got counted twice. So basically it's like saying the 26 cards that are red, I'm going to take the 10 out of those because I'm going to count them as the even cards as well. So 26 plus 20 is 46, minus 10 leaves me with 36 different ways to draw a card that's either red or even. Now in general, if I'm picking 2 different events and trying to find out what's the probability, or how many different ways there are to pick either one or the other, I can add up each of the individual events and subtract out where they overlap. And my note that I have there at the bottom says if the events are mutually exclusive, then that last little section, the in parentheses A and B, that's just going to equal 0. So when it's mutually exclusive, it's just A plus B. If it's not mutually exclusive, it's A plus B minus the overlap.